AP Calculus FRQ Part 3 with graphical explanation. We're going to look at C and D now. Okay? All right, so we talked about this problem already before. Particle is moving along a curve. The x prime of t, the derivative x component, y component are given. The velocity vectors at time t is 0. We need to find for C the y coordinate at time t equals 0. So we already know the position of at 2 at time t is 2, y of 2 is 6. And so that is a given, and then the y prime of t is also known. So we want to find the y coordinate at time of t equals 0. This can be found out by basically by integrating the velocity vector, the y component of the velocity vector, and then essentially using we have a known value of y of 2 equals 6. By using the known value, we can set up our integral. So what we're going to do is set it up this way. So we're going to integrate from 0 to 2 of the velocity vector of the y component of the velocity vector. This is basically displacement. You know that when you integrate velocity, you're going to get back to displacement. So this is going to be the known position y of 2 minus y of 0. So this is what we are trying to get at. So when you rearrange that, y of 0 is going to be y of 2 minus our integral from 0 to 2, which is the accumulation of our displacement here. So when we go ahead and plug in the values, I'm going to get y of 2 is 6, and this integral I'm going to use x instead of t, and then put it in my scientific calculator between the interval 0 to 2. So to find the accumulation of the displacement from using through the velocity y component velocity vector. So we go ahead and use a calculator for that, and we calculate that to be negative 1.17 centimeters at time t of 0. Okay, good. So part D, the particle remains in the first quadrant out here. Find all time intervals in the interval between 2 and 8 seconds. The particle is moving towards the x-axis. So moving towards the x-axis means that means the y component of the velocity vector rate of change has to be negative. So we're going to set our velocity, the y component of velocity vector is less than 0, which is this less than 0. So now you can move this to the other side, square both sides, and then we'll get this nice quadratic equation, which is essentially going to be so here basically we squared both sides and then move this back this way. So now it's going to be t squared minus t 1.2 plus 20. So rearranging that greater than 0, and the root of that we can find to be 5.22. So what is the meaning of that? Well, let's look at the graph. So we'll come to our answer in just a minute, but when you look at the graph, you'll see this is the derivative, the y component derivative is positive, 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 positive. It'll come to this point t of 5.22, after which starts getting negative. That means going towards the x-axis in between 5.22 and 8. So that's where the particle is moving towards the x-axis, where the y component or the derivative of the rate of change is going to be negative in this in this case. Okay. All right. I hope you enjoyed this. I'll talk to you in the next video. Have a nice day. Bye.